This is 2.7 part 1. We're going to be looking at linear and absolute value inequalities. So the first thing we need to do before we jump in is look over our different notations. So inequality notation, set builder notation, and interval notation, which you should have seen in Algebra 2. So first of all, for each row, you're going to be given a different bit of information, and we're going to take that and put it in the 3 different forms that are left blank. So on the first one, it says x is greater than or equal to 6. X is greater than or equal to 6. So if I put that on a number line, I'm going to put my 6, and I'm greater than or equal to that. So I'm going to shade to the right, and I will have a closed circle. So you get a closed circle when you do have the equal to, and remember when you don't have the equal to, you're going to have that open circle. So you've got a point at 6, and then it's shaded to the right. Now set builder is very similar. It just takes it's similar to inequality. It just takes the inequality and you're going to put it in a fancy notation. So you get these curly brackets, and then you're going to say x such that, and then you're going to insert the inequality. X is greater than or equal to 6, and then close it. So let's see what that says in words. So what that says versus just x is greater than or equal to 6, this says the set of all x, so these parentheses, these curly brackets, those are the set, and then of all x, such that, that bar means such that, x is greater than or equal to 6. Okay, so all of that just makes up just a more proper way to write your answer. It kind of makes it a complete sentence in math language. Okay, and then writing that in interval notation. Interval is my favorite just because it's like pretty straightforward. It's to the point and nice and easy. So you're going to start with your leftmost number. So if you look at the number line, my leftmost number is going to be 6. And then if it's if that number is included, so it's a closed circle or it's equal to or any of those things, you're going to have a square bracket. So that tells me that the 6 is included in this interval. And then you put your rightmost point. So looking over here at my number line, I'm shaded all the way to the right, and then there's an arrow, so that means infinity. My rightmost number would be infinity. And anytime you use infinity, you're going to put a parentheses. All right, so next one, we're starting with interval notation. So let's put that on a number line. Okay, so -5, -1. So like I said, if there's a square bracket, that means the point is included. So it's going to be a point at that number, a closed circle. However, if there's a parentheses, then that means that number is not included. And to denote that on a number line, you're going to put a open circle. So this 1 is included, the -1 I mean, and then the -5 is not included. Everything all the way up to -5 is included, but not the -5. All right, and then obviously every number in between is also shaded. Okay, so in inequality notation, you can put the x in the middle. X has to be greater than -5, right? We're shading to the right of -5, and it's not equal to because that's an open circle. And then it needs to be less than or equal to. -1. Since that one, since the -1 is included, you need the equal to there. Okay, in set builder, x such that, the set of all x such that, and then just write your inequality. -5 is less than x is less than or equal to -1. All right, so there's our problem for the third one. So we're starting with the number line. We want to write that in inequality notation. So on this one, it's actually going to be a little bit different. So if you look at the first shaded part, it's shaded from 4 and then all the way to the left. So x has to be less than or equal to 4, since we have a point there, or and then look at the next shaded part. So if the two shaded parts are separate, you're going to have two separate inequalities. So x is greater than or equal to 7. Okay, so two separate inequalities, and you can write that in set builder. Is set of all x such that x is less than or equal to 4, or x is greater than or equal to 7. So it can be in either place, either or. Okay, now writing this in interval notation. So we start from our leftmost shaded part, so that's going to be -infinity. And on the infinities, we always get parentheses. Then we go all the way up to 4, but we have to stop there. So we're going to stop at 4. We're going to use a square bracket because it's a point at 4. The 4 is included. Then we use this symbol. It's called a union. It's going to tie those two together. And then we start with our next shaded part. So the leftmost part of our next shaded part is 7. So square bracket 7. Then it goes on forever and ever to infinity. So that's infinity parentheses. All right, next one. So moving that to inequality is very easy, right? Just take the inequality out. Let's put that on a number line. Okay, so we've got to have our numbers 1 and 7. And x is greater than 1, open circle, less than 7, open circle. So shade in between. Then interval notation, you're going to have your leftmost number 1, your rightmost number 7, parentheses on both because neither of those are included. Both of those are open circles. The numbers are not included in the set, so you'll use parentheses. Okay, next one, we've got our interval, which has -infinity, 10. So on a number line, you're shading all the way to the left. That's that -infinity. And then it stops at your 10. Okay, so we've got all of that is shaded. And since there's a square bracket on the 10, that means that point is included, which means it gets a closed circle. Okay, so writing that in inequality notation looks like x has to be less than or equal to 10. So we have the set of all x such that x is less than or equal to 10. Last one. Okay, so we've got another or here. So you've got, and this one's actually very interesting. So let me draw my number line. Okay, so it looks like x is greater than -2, greater than -2, less than or equal to 1. Okay, so I've got that part shaded. Or x is greater than 3, so here's 3, greater than, so open circle, or and then less than or equal to 5. Okay, so we got two different shaded parts on that one. Okay, so in set builder, the set of all x such that -2 is less than x is less than or equal to 1, or 3 is less than x is less than or equal to 5. And in interval, so leftmost number, -2, open parentheses there because it's an open circle, up to 1, union, parentheses, 3, 5. Okay, so going from left to right on each shaded part and joining them with that union symbol. All right, now let's get into solving some inequalities. So properties of inequalities. Let A, B, and C represent real numbers. Then if A is less than B, then A plus C is less than A plus C. So that's just saying you can add a number to both sides of the inequality and the inequality is still going to hold. Number 2, if A is less than B and C is greater than 0, so C has to be positive, then you can multiply by C on both sides and the inequality still holds. Number 3, if A is less than B and C is less than 0, so C is negative, then AC is greater than BC. So notice the inequality flipped. When you multiplied by a negative C. Okay, so that's exactly it. So look at my bold statement. We can solve inequalities the same way we solve equations, but we must remember to flip or reverse or whatever word you want to use. You need to flip that inequality when multiplying or dividing by a negative number. So if you're solving it and you need to multiply or divide by a negative number in order to solve, just make sure you flip the inequality. All right, let's try this on number 1. Solve the inequality and write the solution in interval notation and graph it on a number line. All right, so solving for x. So pretend that's an equal sign in between there and solve for x. So subtract the 3 and I will subtract the 2x on both sides. So I've got -6x is greater than or equal to 5. And then I'll divide by -6 on both sides. So I just divided by a -6. We know what that means. I need to flip the inequality. So that's going to become less than or equal to. So x is less than or equal to -5/6. All right, so writing that in interval notation, you can draw the number line first if that helps you write it. So if it's less than or equal to -5/6, then it needs to go from -infinity to -5/6. Since I have the equal to, I get the square bracket on the -5/6. Okay, and now on my number line, I'll have -5/6, close circle, since we're including that number, and then we're going to the left. X is less than that, so we go to the left. All right, number 2. So solving this as though it were an equation. Just make sure if you have to divide by a negative, you flip the inequality. So 3 over 5, I'm adding the 4 on both sides. Okay, so I need a common denominator. So adding 4 is the same thing as adding 8 over 2. So I'm going to add 8 over 2. So we're adding the numerators. Negative 5 plus 8 is 3 over 2. Okay, now to get rid of the 3/5, I'm going to multiply by 5/3. Multiply by the reciprocal. Okay, so that cancels. So x is greater than, and look, so I'm doing 3 times 5 over 2 times 3. Those two 3's are going to cancel. Remember that from when we did rational expressions. So I'm left with 5/2. X is greater than 5/2. Greater than, so writing this in interval, I'm going to have 5/2, comma, infinity. Parentheses because it's not equal to. Okay, and then writing this in on a number line, I'll have 5/2. And then greater than that, so open circle to the right. All right, number 3. So this one is called a compound inequality. So solving for x, you just need to make sure that, so you're trying to isolate this x that's in the middle. Make sure that whatever you do to the middle, you do to both sides over here. So you're going to do it to both outsides. So first, add the 8. And then divide by 6. Okay, so x, this side reduces to 3/2. This side reduces to 2. Okay, so putting that in interval notation is just going to be square bracket 3 over 2, comma 2, square bracket. And then on a number line, I'll have my 3/2, my 2. X is greater than or equal to 3/2. So closed circle, shading to the right. And less than or equal to 2. Okay. And the last one we'll look at today. So dividing by, oh, I lied. We're going to do the word problem as well, and then we'll be done. Okay, so solving this for x, we're going to divide by -2. You could distribute the -2 if you'd rather, and then solve, but I'm just going to divide by -2 to get rid of that. Notice dividing by -2 is going to make me flip the inequalities. So just divide by -2, divide by -2 everywhere. It gives me -4, and then I have -10. But I need to flip those inequalities. So now it's that way and that way. X plus 5. Okay, now I'll continue solving. So subtract 5. That gives me -9 is greater than x is greater than or equal to -15. Okay, so let's put that on a number line before we put it in interval notation this time. Because -15 is less than -9. Okay, so we need to be careful about that. So it says x is less than -9. So open circle to the left. And then greater than or equal to -15. Okay, so there it is shaded. So now writing that in interval notation, you've got -15, comma -9. And then you need a square bracket here and a parentheses there. Okay. Last one, our application, which is finding a break-even point. So basically it's the type of problem where you're saying in order to make a product, you have to spend a certain amount of money. So at what point will I make enough money to pay for the cost of production? At what point will I make enough money to pay for the cost of making the item in the first place? So we've got a revenue equation, and revenue is how much money you get total. So you're selling a product, you earn a bunch of money, that's the revenue. The cost, so it's the revenue is your the money before you subtract the cost. Cost is obviously the cost of actually creating the item and selling it. And so we are looking at, it says where X is the number of units produced and sold. So X is the amount of items that they make and sell. It says what production level will the revenue at least cover the cost of production, right? Because there's no point in making the item if I'm not going to make at least be able to pay for it in the first place. We don't want to lose money when we're doing business. Okay, so at what production level, so at what X, will the revenue at least cover the cost? So we want revenue to be at least the cost. Revenue is greater than or equal to cost. So that's 45x is greater than or equal to 30x plus 5250. And then we solve for x. So subtract the 30x. And you can divide that by 15. Got 350. So they need to make at least 350 items and sell them in order to cover the cost in the first place. So if you're not going to sell 350, you may as well just not do it. All right, unless you want to lose money. Okay, so x needs to be greater than or equal to 350.